All right, so talk to me about some of the technology that ExPost and Carbon Critical are working on.
So, because we understand the nature of lithium-ion batteries, especially the mechanism why it catch fire, so we identified removing electrolyte and that will neutralize the whole system. So we're actually working on a project developing new method to completely extract the electrolyte from the cell. We're not only talking about the
Mm.
solvent, but we're also talking about the salt associated with the lithium-ion batteries. So the reason behind are very straightforward. So in terms of the hazardous level of lithium-ion batteries, we are actually talking about two different types of hazardous waste. One we call the electrochemical hazardous. Another one is a chemical hazardous. So when we talk about the lithium-ion batteries catching fire, we're actually talking about the first one, which is electrochemical hazardous. And people typically ignore the chemical hazardous risk associated with lithium batteries. So in our project, we are developing new extraction method and to completely remove the electrochemical hazardous as well as the chemical hazardous. So that's the project me and James are working on.
And can you tell us a little bit about some of those processes to remove the chemical hazards?
Yeah, so of course, sure, we start to identify the lithium-ion batteries for sure, and then we still go through a safety shredding process. This shredding is associated with an inert environment, as well as a very, I would say it's a environment to control the atmosphere inside the shredding unit. So we drastically prevent any potential fire hazards or explosion that can happen during the shredding. And the next phase is actually we call it extraction, which is we are using special chemicals to extract the solvent and the salt of the electrolyte out of the shreds.
Mm.
So the shreds is a lithium-ion battery shreds, and of course, once we shred the batteries, all the inside components will be exposed, and then that's where we get a chance to completely extract the solvent and the salt from the shred. And by separating the electrolyte from the cathode, anode, or other components of the batteries, we drastically mitigate the fire potential or explosion opportunity of the batteries. So that's what we're doing.
All right, so how does the technology that Carbon Critical brings fit into this process? James, Mike.
So, Carbon Critical is a domain expert in the use of supercritical carbon dioxide for um, industrial processes. And this fits or aligns perfectly with our core expertise in that field. We found that supercritical fluids, supercritical CO2 in particular, is a highly effective solvent to remove electrolyte. And also, it is, of course, an inert gas, so there is no fire risk when working in that
Mm.
CO2 atmosphere. And it's an effective heat transfer media. So it actually can perform three roles in this instance and can do them without releasing any toxic compounds to the external environment. The working fluid is completely recyclable, so no fluids are ever lost. And there's minimal need to replenish fluids in the process, and there's no waste stream associated with the working fluid. So, in that sense, the supercritical fluid, once you've made the capital investment to generate and contain these supercritical fluids, the fluid itself is infinitely recyclable. The cost is almost nothing, and it is highly effective in the sense that it performs these three functions simultaneously.